Hi everybody! So in today's video I'm going to teach the same thing that we went over today in class. That way if you need another chance to hear these words, or if you weren't here today in class, you're going to have the chance to learn what it is that you missed. So today in class we learned about finding the derivative of an inverse function. Now, just like when we were finding the derivative implicitly, this is a process and not just a rule that you have to learn. Finding the derivative of an inverse function is a process that we follow and not just a rule that we have to learn. So here's an example of inverse functions so that we can review what this means in math. In math, if I say that y equals 2x is a function, then the inverse function would be y equals 1/2 x. The reason that these are inverses is that if I were to make a table of values for this first function, then an example of numbers that would go in this table would be, if we start with -1, 0, and then 1. If I plug in -1, I get -2. If I plug in 0, I get 0, and if I plug in 1, I get 2. The reason we would consider these functions inverses is because if we make a table of values for this one, if I plug in what used to be my outputs as the inputs in this table, you'll notice that what used to be my inputs now become my outputs by plugging them into the equation. So we consider these inverses because the functions are the reverse of each other. Inverse is kind of like thinking about reverse. It's a function that reverses the inputs and the outputs for another function. Now, another way that we sometimes write this is this. If f of x equals y, then suppose g of x is the inverse of f. So suppose these are inverses. If f of x equals y, then we would be able to say that g of y equals x. Because since g is the inverse, it would reverse the inputs and the outputs. That's going to be really important that the x's and y's, the inputs and outputs, switch for inverses when we start to follow the procedure for finding these inverse derivatives. So here's how we find the derivative of an inverse. In the problems that we're doing, in the directions, we are going to be told that g of x is the inverse of f of x. So it's the inverse of f. In order to find the derivative here, I want to be working with the original function, not the inverse. And we're going to be asked to find g prime. I should have mentioned that earlier. So in order to find g prime, that would mean I would need to take the derivative of an inverse function. But since that's not something I know how to do, we're going to rewrite this in a new way that's going to make it easier for us to take the derivative. If g of x is the inverse of f, then I can take f of both sides and write this in a different way. So instead of saying g of x equals the inverse of f, I could just take f of both sides. F of g of x now, f and f inverse are opposites, so they cancel, is just x. From here, I can take the derivative. To take the derivative of the left side, I would do the derivative of the outside and then leave the inside alone times the derivative of the inside. To take the derivative on the right-hand side, I would just take the derivative of x, which is 1. Now remember, our goal here was to find g prime of x. What you'll notice is that g prime of x is now part of what's on the left side of this equation. So to get g prime of x by itself, I would just divide by f prime of g of x. So g prime of x would equal 1 over f prime of g of x. This process of rewriting the problem so that we don't have inverses, taking the derivative using chain rule, and then solving for the derivative we wanted is the process that we're going to follow every time. So here's how I would explain what to do in words. First, rewrite the problem so that there are no inverses. Then, take the derivative using chain rule. Next, solve for your required derivative. Now, in a real problem that we're going to do, the last step would be to substitute your values and calculate the derivative from there. So let's take a look at what this looks like, how the problems are worded, and how you're going to do the problems. So on the next page, this is a very typical word problem that is part of the multiple choice part or the free response part of the AP test. It says, let f be the function defined here. So we know f. If g is equal to the inverse of f and f of 1 equals 10, what is the value of g prime of 10? The first thing I want you to know here is that we have an equation where g is the inverse of f, and we are asked to find the derivative of g. Since we don't want to have to find the derivative of the inverse of f, we're going to rewrite this in a different way. So step 1 here is going to be to rewrite this equation in a different way. So to rewrite this in a different way, I'm just going to apply the function f to both sides. So on the left side, I'm going to have f of g of x. And on the right side, I'm just going to have x, because the f and the f inverse will cancel each other out. They undo each other. Now from here, I'm going to, so this was step 1, which was rewrite. From here, I'm going to use chain rule. So take the derivative using chain rule. So the derivative of the left side, I would take the derivative of the outside, leave the inside alone, times the derivative of the inside. And on the right side, I would take the derivative of x, which is just 1. Now I'm going to solve for my desired derivative. In this case, I'm going to solve for g prime, because that's what I'm trying to figure out in this problem. And g prime of x is right here. So I'm going to have g prime of x equals 1 over the derivative of f of g of x. Now my fourth step is going to be to plug in the number 10, because I was asked to find g prime of 10. So I'm going to substitute my value, and I'm going to calculate my answer. So instead of x here in this equation, and instead of x here, I'm going to plug in the number 10. So g prime of 10 equals 1 over f prime of g of 10. Now, in order to evaluate this, I'm going to need to work my way from the inside out. So I'm going to start with g of 10. Unfortunately, to find g of 10, I would need to know one of two things. Either g of x, so I could plug in the number 10, and if I read the original instructions here, I don't know g of x, I only know f. Or I would need to know the other way to do this, which is to say if f of 1 equals 10, then g of 10 equals 1, because g is the inverse of f. So because f of 1 equals 10 tells me that g of 10 equals 1, I know that g of 10 is 1. So my next step of this problem is to say g prime of 10 equals 1 over f prime of 1. Now f prime of 1 I can figure out by taking the derivative of f and plugging in the number 1. So the derivative of f would be 3x squared plus 7, which means f prime of 1 would just be 10. What this means is that g prime of 10 would be 1 over 10. And that's my answer. Let's try another problem to work through these 4 steps. Rewrite, chain rule, solve, substitute, and calculate. For problem number 2, it says let f be the function defined by f of x if g is the inverse of f and f of 1 is 7, what is the value of g prime of 7? So the first thing I need to recognize is that g is the inverse of f. Step number 1 is going to be to rewrite this equation so that it does not have an inverse. To do that, I'm going to take f of both sides. F and f inverse cancel because they're opposites, so my rewritten equation would be f of g of x equals just x. Step 2 now is going to be to use the chain rule to take the derivative. So I'm going to have f prime of g of x times g prime of x equals the derivative of x, which is 1. Now I'm going to get g prime of x by itself because I'm asked here to find the value of g prime. So step number 3 is to say g prime of x equals 1 over f prime of g of x. Now that I have this equation, step 4 is to substitute and solve. So I want to find g prime of 7, which means I need to figure out 1 over f prime of g of 7. In order to find g of 7, I would either need to know g of x's function, so I could plug in the number 7, or I need to know the relationship between inverse functions. What the relationship between inverse functions tells me is that if f of 1 is 7, then g of 7 is 1. So my new problem that I'm trying to simplify is g prime of 7 equals 1 over f prime of 1. In order to find f prime of 1, I'm just going to use the f of x function that I know and plug in the number 1 to the derivative. So f prime of x is 21x squared plus 3 times the natural log of x squared times the derivative of the inside, which is 1 over x. If I plug in the number 1, I'm going to have 21 plus 3 times the natural log of 1 squared times 1 over 1. Now the natural log of 1 is 0, so this would just be 21. So my final answer here would be g prime of 7 equals 1 over 21. Last but not least, let f be the function defined by f of x if g of x is equal to f inverse of x, so that's the key, is that these are inverses, and g of 2 equals 1, what is g prime of 2? So to find g prime, I'm going to start by rewriting this problem so that I don't have an inverse function anymore. So I'm going to find f of g of x and f of f inverse, because the f and the f inverse will cancel. So my new equation is f of g of x equals x. Step 2 is going to be to find the derivative. So take the derivative of the outside, leave the inside alone, times the derivative of the inside equals 1. Next, I'm going to solve to get g prime by itself because I'm trying to find g prime. So g prime of x would equal 1 over f prime of g of x. Step number 4 now is to substitute in my value, and my value in this problem is 2. So g prime of 2 would be 1 over f prime of g of 2. To find g of 2, I either need to know g of x's function or realize that I was actually told that in the instructions. So I would have g prime of 2 equals 1 over f prime of 1. Now I'm going to use the function that I was given. I'm going to find f prime, which would be 3x squared plus 1. I'm going to plug in the number 1, which gives me 4. And so I know that g prime of 2 would be 1 over 4. That is the answer. Thank you guys so much for watching. I hope that if you needed to hear this again or needed some more example problems that this was helpful, and I will see you for some practice in class.